the second thing I'll talk about. Ben and I are here to talk about two efforts that we're both a part of, standardization efforts in the Sparse community. Ben will be talking about the Sparse BLAs, unifying Sparse BLAs vendors. And I will talk about the Binsparse format. It's a file format for sparse tensors. This effort goes back a couple years now to the 21 Graph BLAs Forum, where Eric Welch introduced the idea that we should really start coming up with a better format than Matrix Market for sparse arrays and tensors. And so this is the result of that. Why do we store sparse matrices and tensors? What's the point of this? One reason is to share data with other scientists, right? We might have a standard set of test matrices like the SuiteSparse collection. I know Julia has a really great package for working with those matrices called Matrix Depot, I think. You might also want to pass data between frameworks, right? If you have different tools written in different languages, how does the sparse matrix get from one place to another? Oftentimes it's the file system. You might also want to have an in-memory data format, and that's another reason to use this. Another reason you might do this is to save results to use them later on your own system, right? Like if you're trying to do some sort of checkpointing or serialization, this is another reason we need these file formats. I think almost, and you could almost call it a little bit of a rite of passage of learning about the sparse ecosystem is learning about how Matrix Market works. And I think many people in here may have written their own Matrix Market parser at some point in their career. The way it works is it's a text format. You have your description of the overall parameters, and then it's a list of tuples in text format of the matrix. You have coordinates followed by values. There's a couple of reasons that these kind of text-based formats are not ideal. One is that they're not fast. Another reason that they can be a little bit, and this is a complicated argument because it actually, sometimes they are inefficient in their storage. Sometimes they're actually more efficient than storing floats, and we can talk a little bit about that. But for the most part, these text-based formats are less efficient, both in runtime and storage costs. We talked a little bit. They're big. You use a whole byte for every digit. It's also expensive to parse. Even the fastest Matrix Market parser doesn't even saturate the memory bandwidth, which is we can do better. We're storing a matrix. One of the reasons this is another reason that Matrix Market is kind of not ideal is that we just talked about all of the different sparse matrix formats that exist in the ecosystem, right? We have the CSR and the COO formats, and we have SELL, right? So Matrix Market doesn't consider the format. So before you store your matrix, first you need to convert it into COO, and then you can serialize it to text. And this is the state of the art still. Oftentimes, because it's slow, people develop their own custom formats, right? We have a couple one-off implementations of binary storage for sparse matrices. But of course, it's not portable, right? Because we kind of need a standard for everybody to be able to be in on it. So if we can have this standard, then everybody is able to, no matter where you are, write your sparse matrix to binary, and then anyone else can read it without you two actually having to communicate. So this is the, ta-da, we implemented Binsparse. Binsparse stands for binary sparse. And the idea behind it is that there's a JSON header that describes your sparse format, describes your fill value, what kind of things are you storing, is it symmetric, right? These kinds of things all live in JSON, describes the size of the matrix or tensor. And then there's going to be one or more dense arrays, right? These constituent sparse array buffers stored in a binary container, something like HDF5, Zarr. It could be NPZ if you're old school and you want to work with Python. One of the benefits of doing it this way is that we can support many sparse matrix formats. So we can support dense vectors. We also have hard-coded formats for all of the major sparse array formats, right? row major, DCSR, CSR. We also have a couple structural annotations for like symmetry. And the Binsparse matrix under the hood looks a little bit like this, where we have these named fields of like the pointers and the indices. We also support custom formats in Binsparse. So I was talking a little bit about how we can conceptualize formats as trees. And this is reflected in the Binsparse standard. So the Binsparse standard also includes a couple annotations, and you can build your own tensor or format that fits your use case. So this is how we handle the 4-dimensional cases where maybe the formats are a little less standard. So it's pretty similar to the taco specification. You have things like, this nested JSON description that has like dense and sparse, and then at the very end you have your like leaf level, which is a bunch of elements. And we've seen this before. So in practice, we have a reference parser in HDF5. It stores the JSON descriptor in the group attribute of the HDF5 object. All of this was really easy to do for, Finch supports Binsparse. And it was easy to do because there was an HDF5.jl. And so it was like pretty straightforward. Many thanks to those who have developed that package. But we store the JSON descriptor in the group attribute of the Binsparse object. And so this is like a lot of these binary containers have this capability to store headers or things like that about the data. And one of the benefits of doing it this way is that we can support multiple matrices in the same HDF5 file by like having different subgroups for each matrix. And then we have a little bit of data showing what I think you could expect, but I mean, still we will show you. It is actually faster than storing it in text, even the fastest matrix market parser known to man. We can be faster using this Binsparse format. So here, this is the MTX. This line on the top is the file size of an uncompressed matrix market file, and then down here we see some of the Binsparse formats for COO and CSR in uncompressed and compressed file sizes. So we see like an average reduction here for these various representations, and if it's just for CSR, then we're seeing like average reduction of about a factor of 2, a little bit more. Then we can also talk about like the speed at which this happens. And by the way, this on the x-axis, it's the file size in Matrix Market, like the original file size before we started all this. Each dot represents a singular matrix from the SuiteSparse Matrix Collection, and this graph has all of the matrices from the SuiteSparse Matrix Collection. Is it missing 1 or 2, or?
With more than 1 million non-zeros.
With more than 1 million non-zeros. So we left all the small ones out of there because we didn't want our header to mess stuff up. But yeah, so I actually you can see that the read times are also improved by a similar factor, maybe a little bit more. We see like an average speed up of 4x in terms of like read and write times for sparse matrices, which is good. And I think with that, I want to leave it up to questions. So you can check out the specification online. I encourage you to contribute if you have thoughts and opinions about sparse matrix file storage. We have, bi-weekly meetings. We're still standardizing a little bit, approaching 1.0. And I want to take questions because I think your feedback is really valuable. So I'll stop there. Yeah, go ahead.
Why gzip rather than like LZ4 or Z standard?
We're going to have to, I think we just chose a popular compression technique. Yeah.
So the reason is because gzip is built into HDF5. Oh, sure. Yeah, so the reason is only because gzip is built into HDF5 in pretty much all distributions, whereas it may be different in Julia, but at least from the C perspective, you have to set up your own custom like compression setup for LZ4. So for this experiment, we just wanted to use like the tools that are easy out of the box. But in terms of Binsparse, you can use whatever kind of compression or indeed binary storage you want, right? The main thing we're specifying is basically the JSON and how that corresponds to something in memory, right? And you can use whatever storage you want.
This is a very simple question. What did the matrix do that made that made you worse than Matrix Market?
Yeah, Ben's going to answer.
So this is a very old couple of, I think 3 matrices from the Harwell-Boeing collection, which goes back before Rutherford-Boeing. And those are matrices that contain some real values that are succinctly expressible in text. For example, like we have this in the paper. I think it's like 0.7.
Right.
That's
0.7 is not like rationally expressible as a floating point number.
Yeah, it's not expressible as a float 64, right? And so the minimization process we used is basically we read in the Binsparse or the original Matrix Market file as a FP64, and then we tried to downcast to a lower precision. And if we had a different result, then we consider this, we have to store it in FP64. So in that case, Matrix Market is storing 2 bytes, right? And we're storing 64. Yeah. But for most matrices, that's not a problem. Yeah.
Right, those are clearly extreme.
Yeah. And this is also partly an artifact of like how Tim Davis generates the SuiteSparse Matrix Collection. Yeah, we can talk more about that offline.
I have a question about like coverage of weird matrix formats. So like, I've been in some of the Binsparse meetings here and there, but like, how much of the potentially infinite like Finch formats can you actually store natively, I guess, in Binsparse? What's your sense of that, I guess?
So currently it's combinations of dense and sparse. Some Finch formats are optimized for runtime rather than for storage. So like Finch has variations on like it's a hash table, it's a tree. These things all look the same when you compress them down into just a sorted list of non-zeros. But I think that the same paradigm could easily store something like a run length encoded array or something like that if you just want to add that particular level format to the standard. The other extension that we're working on is reshaping so that you can support block formats. So we'll have an extension in Binsparse. You can comment on the PR about reshaped sparse matrices to get something like B CSR or like a batched sparse matrix. OK, I think with that, it's up to Ben to close out the session today.
I have one final question, which is, can you read these files from Julia?
Yes, you can read these files from Julia. You just need to using finch.jl. So that currently we have a finch.jl parser. I imagine if someone feels motivated and inspired, you can implement your own like sparse arrays.jl parser. Yeah, you can also, once you've implemented your Binsparse parser, many languages will be available to you, including C and Python. And so you can pass your matrices to these frameworks as well.
SuiteSparse also has a parser, right?
Not yet. We're working on it.
Oh, yes.
Right? Okay. Yeah, I think under construction, open to contributions. Yep, cool. All right.